Okay, I'm going to do the practice problem number 1 to try to help you guys out with some of the math that you may be having trouble with on the series circuit. So first, let's go over the rules. It says, don't forget the rules. So to find resistance for the series circuit, remember resistors, the unit for resistance is ohms. So anything you see with an ohms, those are going to be the resistors. So I'm going to label these resistor 1, resistor 2, resistor 3. So these are actually going to be givens in the problem. So resistor 1 given is 20 ohms. Resistor 2 is 30 ohms. Resistor 3 is 50 ohms. Okay, and then it says to find the total resistance, RT, all you do is add those three things up, the three resistors. So you do 20, 30, and 50. Okay, so 20 plus 30 plus 50. So you're going to get 100 ohms. And all I did here was 20 plus 30 plus 50. So the total resistance in this circuit is going to be 100 ohms. Then, what else, I did the three givens here. I also have 125 volts. Now that is going to be the total voltage of this whole circuit. So I'm going to put 125 volts in that spot right there, since that's the T stands for total. Okay, so given what we have now, so let me write my steps out here actually. So step 1, I found RT. So we did that here. Step 2, I guess I wrote all the givens, but wrote VT, and I'm going to put here it's given. All right, step 3, I can solve for the total current. So if I have the total resistance and the total voltage, I can solve for the total current in the resistor. So I'm going to use V equals IR. And I'm using the total values for all of these to find the total here. So the total voltage is 125. I don't know I. And then the total resistance is 100. So I'm going to divide 100. So 125 divided by 100 is 1.25 amps. Okay. So I'm going to write that here. Found IT, and to do that, I used V equals IR. My fourth step is going to be to look at my next rule up here. It says current stays the same at each resistor. So if current is equal to equal, all three, I'm just going to put, I solved for it here, so 1.25, 1.25, 1.25. Those are all amps. Okay, so found the current at 1, the current at 2, and the current at 3. And again, in a series circuit, they're just all equal. Equal, 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 equal. Okay. And then step 5, I'm going to solve for the voltage drop at each resistor. And to do that, I'm going to use V equals IR again, but this time I'm not going to use the totals because I'm not looking for the total. I'm actually looking for the drop. So I'm going to use V equals IR, but I'm going to use the I from this row and the resistance from this row as well. So V equals 1.25 and 20 times 20. So I'm going to do the math. 1.25 times 20 is 25. So the voltage drop at resistor 1 is 25 volts. Okay, and then V2, I'm going to use V equals IR again. I'm looking for the voltage drop. I is going to be the current, which stays the same in a series, so 1.25. And then the resistor at the second spot is the 30. So 1.25 times 30 is 37.5 volts. So that would be the voltage drop at the second resistor. And then the voltage drop at the third resistor, V equals IR again. V equals, this stays the same. And the resistance changes due from whatever is given at that location, and that's going to be 50 here. 1.25 times 50 is 62.5 volts. So that, now I've solved for everything. Now if you wanted to check your work, 62.5, 37.5, and 25 should, when you add those up, should equal 125. And that is how you solve a series circuit.